Whoa! So I'm a little late. I was getting stuff set up. Oh, geometry. It is May 21st. It's a Thursday. We're getting there. We got like less than 10 days of school left. We would normally be prepping for finals about now, I think. No, we'd be finishing up this chapter, like we are. We're not going to have a final, right? So we won't be doing finals prep. We will, however, what the hell happened? We will be doing some review stuff, or just stuff that I'm like, oh, this is interesting. We might do some more Zoom meetings towards the beginning of June, just because I want to give you opportunity. If you're like, I need to get my grade up, I don't understand this concept, I can help with those things. Specific assignments that kind of thing. Do for review. But we're in the midst of chapter 12, probability chapter. The student journal is in the Dropbox already, so if you want to use that, you can. We're mostly going to use it for some vocab. There's some problems in there that I don't think we will do. I'm just going to use some real world examples and talk about dice and cards and stuff. Nothing like super complicated, but we will get there. Stream seems laggy. That's about. I'm just going to continue. Okay, so student journal has some vocab words. On Tuesday, we talked about sample space, which is all the possible options of an event. An event is like rolling a die, drawing a card, the outcome being what happens, and we can predict with probability the likelihood of certain things happening or not happening. This applies to all sorts of things. We're going to do really simplistic examples, but you can extrapolate these things to bigger things like what's the probability that these two countries go to war? There are mathematical simulations for that. Or what's the probability that I get sick when I go out into public? There's mathematical stuff for that. Or car accidents, or any sort of shark attacks, right? Stuff like that. So we're going to talk about today independent and dependent events. So independent and dependent have mathematical meanings as well as real world meanings. Let's look at the student journal. These are the student journal pages. We have some 3 vocab ideas, and then we'll get into some examples, and then we'll be done for today. Okay? Independent events. Independent meaning they're not connected. If I'm independent from my parents or independent in my life, that means I don't rely on other people. They're not providing for me financially, or they're not feeding me. Independent means I'm disconnected. Okay. If you're independent, if you describe someone as being independent, it means they can do it on their own. They don't need help. Which, maybe unfortunately, we all need help. Dependent events are ones that rely on others, so they're conditional, which is why the next one's conditional probability. It has some set of conditions that have to be met for it to be true. So dependent events, something happens, the event after that one relies on the first event, so they go kind of in order. And that first event, whatever happens, changes everything after it. Okay, so independent events, rolling a die, rolling it again. The first one and the second one are not connected. Dependent would be more like drawing cards. So we'll talk about that in a second. So we're going to start by looking at some tables, creating some tables of all the possible outcomes for some independent and dependent events. So let's go here. We're not talking about some drawing. All right, so I have a 6-sided die. We'll start with this. Man, my camera, I don't understand why it started doing this. Hopefully that fixes the lag. No, it didn't. Super laggy. Just a delay. It's really weird. I don't know. Okay, so die 1 through 6, right? 1 through 6. So here are my possible list of options when I roll the die. I could get a 1, a 2, a 3, a 4, a 5, or a 6. If I roll it again, roll 2, I could get a 1, a 2, a 3, a 4, a 5, or a 6. Those are independent. So my first roll, 1 in 6 chance of getting a 1. Remember, this is 1 out of 6. They're all 1 in 6. I got a 1. I got another 1. Wow. That was a 1 in 36 chance. We multiply the two numbers to find the odds of 2 1s in a row. And remember, we made that big table last time of all the possible additions. This is not quite the same because we're not adding them, but it is the same in the sense that we rolled a 1 and then a 1. This would add to a 2. 2, when we sum the two dice together, it's a 1 in 36 chance. So this is the odds. But these two things are not connected. Now, if we were adding them and we rolled a 1 on the first one, we've now removed the chance that we could get a 12 when we sum them, right? Because there's no possible value on here that's going to add to 1 to get a 6. I would need to roll a 6 first. So if we were summing, the conditional situation would be this first roll affects the probability that the second roll is going to get us to some of these different numbers. But the first roll and the second roll, they're not connected. They have nothing to do with each other. They're independent events individually, right? If I roll a 1 and then a 2, the 1 rolling does not affect the chances that I roll a 2. Not connected. Okay. Now, I got some coins. We're going to connect to this idea. The possible flip options, so I'm going to use F for flip, so flip 1, are either heads or tails. Those are my options. 50% chance, right? 1/2, 1/2, 50-50. Those are fair. We'll talk about fair towards the end of the section. Normally we do a project, we have to come up and create a game. It has to be fair or not fair. You have to explain the math behind which one. But, so then if I flip it again, it's still heads, tails, 1/2, and 1/2. Still 50-50. The first one and the second one are independent of each other. But what if I want a head and then another head? What if I want my second flip, my first flip to be a head and then my second flip to be a head? They're not connected, but they are connected now because I want this outcome. So here is our table of all the possible outcomes. My first flip could be a head. Great. Could be a head. Then it could be, it could be another head. And my first flip could be a head, but then my other flip could have been tails. So here's one option. These are all the options if I flip head first. Okay. Then we could have a tail. We could start with a tail flip. And then it could be a head. And then I could have a tail, and then I could have another tail. These are the 4 possibilities of 2 flips. Flip first, flip second, and these are all the combinations. There's only 4. Which is good because sometimes these get really long, these lists. And so we want a head. Head, head. Here are our 4 options. This is a 1 in 4. There's 4 of them. This is a quarter chance. So the probability of head and then head is 25%. It's a quarter. Just happen to be using a quarter for this. Now, the way we get that number from these numbers is we multiply. So 1/2 times 1/2 gives us a quarter equals 1/2 times 1/2. we're multiplying the fractions, and that gives us this big fraction. Remember, when you multiply fractions, you multiply across, so it's 1 times 1 and 2 times 2, so this is 1 over 4. Okay? So that's a really simple example. But like if I wanted to roll on 2 dice, here's a d8, a d6, and a d4. D meaning die, and then the number being the number of sides. So I have a d4, a d6, and a d8. Any specific number that I want to roll is going to be 1 out of the number of sides. So there's a 1 in 4 chance for any specific number, a 1 in 6 chance for any specific number, and then a 1 in 8. If I want to roll a 1, and then a 4, and then a 3, it's going to be 1/4 times 1/6 times 1 out of 8. Those are the odds that I rolled exactly that when I roll these dice. No, you got a 4, a 7, and a 6. Not even close. But these are really low odds. This fraction, 1/4 times 1/6 times 1/8 is 1 over 24 times 1 over 8, which is, let's see, 160. 8 times 4 is 32, so 192. 1 over 192, almost 1 in 200. Those aren't good odds. Those are not good. That's a low probability. Really low. That means you've got 192 coins, and one of them is red, and you stick your hand in the jar, and the odds of you just randomly getting the red one and none of the other ones, yeah. So, not high. Not actually low in terms of the universe. Like a lot of odds in the world, like the probability of something happening, are much lower than this. And they still happen, but it's because we do so many things. There's so many people doing things that, whatever. Anyway, so independent. Rolling this is not connected to that, is not connected to that. So we roll. We multiply the number. We multiply the fractions to get the total probability. Now that's independent. If we want to talk about dependent things, it means the first event changes the situation. So like a really kind of classic, simple example with dice is if I have 2 dice and I roll one of them, now I've got a 1 in 6 on these d6. So the probability I roll 1 is 1 in 6, right? But let's say now on the second die, we'll just do 4. So I got a 4. Now, this second die, we don't want to roll 4 again. We'll just say every time I roll a 4, I re-roll. Well, that's like removing it from the probability because we're just going to roll. Now, it's not quite because rolling dice. I could literally, it's possible that I literally roll a 4 every single time I roll this. Not probable, but it's possible. That won't happen because the odds are really low of rolling a 4 every single time forever. But if I roll a 4, I re-roll. That changes this almost into a 1 out of 5. Right? Or actually, no, I'm sorry. It changes it into 5 out of 6 because we're getting rid of the 4. We're saying you can't roll 4. Still rolling a 6-sided die. It also kind of changes it into being 1 out of 5. A little. It's not the same fraction. It's not the same math. We'd be calculating a different probability. But we're removing that 4 from the pool. So instead of now being, I could roll anything, 6 out of 6. Now the next one is I can't repeat that number. It's going to be 5 out of 6. Now, better example, cards. So I do not have a normal deck of cards. We're just going to use some simple things here. We're going to use the 1, the 2, 3, 4, 5. So they're all the same color. Now, what's the probability that I draw? I was just shuffle these and draw any of them. Well, it's 1 in 5. I mix these up. There's my card. Well, it was a 1 in 5 chance I got the fruit. But, you know, there's 4 cards left. Right? What if I draw another card? Well, now there's not 5 cards. It's not 1 in 5 anymore. Any random card is going to be a 1 in 4. It's 2. Now any random card is going to be 1 in 3. Now, here let's think about this. What if I want to draw them in order randomly? Well, I need to draw the 5 first, or the 1 first. So I've got 5 cards. There's 2 cards I could start with. So any random in order. It's going to be the same probability twice because we'll do it once, lowest to highest. So just to make the math easier. Lowest to highest. So probability this is a 1. 1 is 3, but 1 in 5, right? There's 1 in here. There's 5 cards. It's 1 in 5. The probability. So we drew the 1. It's 1 in 5 chance. Now we need a 2. Now there's 4 cards. There's only 1 2 in there. 1 in 4. There's a 2. Now I need a 3. Now it's 1 in 3. And then you multiply by 1 and 2. And then there's only, once you get that 3, 4. Once you get to the last card, it's the only possible card. There's 1 out of 1, so it doesn't change anything. So those are low odds that I draw them in order. But what if I don't do lowest or highest to lowest? Sorry, I did the highest to lowest, not those guys. What if we did just in order? Well, now I can start with the 1 or the 5. And there's 5 cards. So there's 2 out of 5 chance that I get a card I can use. 2 out of 5. Now I need a specific card once I get to there, because it needs to either be the 4 or the 2. So now it's 1 out of 4 again. And then we need another specific card. Because let's say we started with 5. Now I need the 4, and then I need the 3, and then I need the 2. But this odds would not care what order we're going in. This would calculate, oh, I could start with the 1 and then do the 2, then the 3, then the 4. Or I could do the 5, because I have 2 options to start with. I can start with the 5 or the 4. But my next fraction that I'm multiplying by, to give me the total odds, is based on the changed state of the deck once I've taken a card out. Right? When we talk about a normal deck of cards with all 52 of them, we draw a random card, well, there's, 52 cards. And then once I take that 1 card out, I've only got 51 cards left. So the odds change. It's a dependent event because it requires that the previous card changes my situation. It changes my situation because my deck changes. Right? If you've ever played card games, not like Hearts or like deck of card games, but like card games like Hearthstone or Magic the Gathering, things that thin your deck, that change what's in your deck, are good usually because they take stuff out, increases the odds of getting what you need in the game because you have less cards to draw from. It's usually good. So dependent events, related, required. That's it for today. Okay, so independent and dependent events are independent, means it doesn't matter what the first thing happened was. The second thing is going to be independent of the first. And so we multiply those two different probabilities, it might be the same probability, and we get our odds of both of those things happening. Or all three, or all four, however many things that we're calculating. Dependent events change the situation, so we have to change our fraction, our probability. Okay, that's it for today. All right, so there's a student journal with some problems in there you can do. Lots of things have to do with marbles drawing out of a hat. We didn't do a lot of examples, but that's the gist of it. Okay, and I'm sure there's Khan Academy stuff if you want to practice probability. Probability is really fun. And I will see you guys Tuesday. Have a good weekend.